the Lang stereo test 2, the yoke prism walk, and so on. And we were addressing 3 categories of retinal input with this testing. First, we wanted to look at my center vision pathway. Next, my peripheral vision pathway and pathways. How was my peripheral vision operating? And lastly, the very, very important, the critically important non-image forming retinal pathways, which I will mention also. Daniel Liss has said, Kish has said that we hear in 3 dimensions, we hear in 3 spaces, and let me remind you, all of that hearing in the 3D world around us gets mapped to these same visual spatial parts of the brain. It doesn't matter where the input is coming from. And in this case, the non-image forming retinal input pathways map back to those same parts of the brain. Our dime-sized center vision accounts for only maybe 1,000th of the spatial world around us, of which we are aware on many levels. It's a tiny dot on the far side of the room. It's a button in the middle of a doorknob when you're sitting on the other side of the room. But all the rest of that, the world, the visual spatial world around us, is something we have to keep track of in our brains. It sets the context for that dime-sized center vision. Neurodevelopmental optometry addresses the major portion of our visual spatial processing beyond center vision. You can't hear, you can't think, you might need glasses. Our hearing maps to spatial images because sound is given meaning through the images in our brain. If I tap a wine glass behind your right shoulder, think what you know. First, you'll recognize it's a wine glass. You might imagine the color red of the wine. You'll evoke all kinds of context level connections to other spatial images, such as that you might drink the wine with someone, and that other people could drink wine, or maybe someone's had too much. All of these are visual spatial images, and they are instantly processed as soon as you hear the sound of the wine glass. The non-image forming retinal pathways. This is a collection of pathways that set our spatial grounding in the world. They branch off to the brain and elsewhere after the retina. This sets the context. It sets the level playing field, the platform on which everything else depends. It sets the context for our peripheral awareness as well as our center vision. It's linked to balance, posture, emotion, hormones, hearing, sleep cycles, spatial awareness, and so on. All humans have the hardware to interpret these signals, including those people who've been blind from birth. We all have the same hardware. It's a crucial part of what makes us human. And I believe when this gets out of sync with the rest of our processing, it can lead to this kind of alienation that I described in the early part of the talk. Zelinsky used the Z-Bell test, her Z-Bell test, at each visit to assess my non-image forming retinal processing and to link it with the 3D spatial hearing of my world, the world around me. We might say you can see 20/20, but your retinal processing is completely dysfunctional. It's common with brain injury. But how happy I am to say that you are now able to say in the modern world, but we can fix that. As an aside, I'd like to mention that my intuition, based on my experience, is that neurodevelopmental optometry can treat many of these cases, these very troubling cases of attention disorder.